Hi students, so in this video we will discuss about finding the volume of a sphere using triple integral. Now we need to find the volume of sphere is what? X square plus y square plus z square equal to a square. So simply he has given the equation of sphere, which is x square plus y square plus z square equal to a square. We need to find the volume of the sphere. Now clearly first we need to find the boundaries of x, y and as well as z. Why? Because we have three variables we have, so that we need to find the boundaries for x and y and then z. So if you want to find the boundaries of x, treat clearly what is the equation of sphere is what? X square plus y square plus z square equal to a square. So that we need to find the boundaries for x, y and as well as z. So that the first integral in terms of other two variables, coming to the integration, first integral in terms of other two variables and the second integral in terms of the other variable what is left, and the third integral in terms of constant. So that if I want to find the boundaries, clearly I have to take z in terms of the other variables, so which is nothing but z square equal to, from this equation, a square minus x square minus y square, and z equal to plus or minus root over a square minus x square minus y square. So that the z value ranges from minus root over a square minus x square minus y square to plus root over a square minus x square minus y square. So clearly z bounds varies from minus root over a square minus x square minus y square to plus root over a square minus x square minus y square. And coming to bounds of y, we need to put z equal to 0. So we can already find the value of z, so that if z equal to 0, if it is 1, from 1 what we have, x square plus y square equal to a square. So now we need to find the value of y. So y square equal to a square minus x square, so that y equal to what? Plus or minus root over a square minus x square. So that clearly y varies from minus root over minus root over a square minus x square to plus root over a square minus x square. So clearly if you want to find the boundaries of x, z in terms of other two variables, y in terms of the other variable, and finally the constant bounds. If you want to find the constant bounds, put y have already bounds and z have already bounds is equal to y, then we will get the constant boundaries. From 1 what we get, x square equal to a square, so that x equal to what? Plus or minus a, so that x clearly varies from minus a to plus a. Now coming to find the volume of the sphere, what it is. In 3D we have 8 octants, we have 8 octants. So instead of taking the bounds are from minus to plus, I need to find the volume of a surface lying in the first octant. So if I want to find the volume of the surface in the first octant times of 8, which gives the result volume of the entire sphere. So please see this. We have 8 octants. So what I am trying to do is, I want to find the volume of the surface in the first octant, and which is multiplied by 8, which gives the entire volume of the sphere. So that coming to the first octant, volume of the 8 times of volume of the surface of sphere lying in the first octant. So clearly volume of sphere, what we need to find? Volume of sphere. So that 8 times of volume of this surface of the sphere lying in the first octant, so which is known as, so please see this, so the volume is equal to 8 times of, coming to the first octants, so we are all having the positive boundaries, so which are ranges from 0 to a. Coming to the x constant bounds, so third integral consists of the constant bounds ranges from 0 to a. Instead of taking minus a to plus a, I need to take 0 to a. Why? Because it is in the first octant. So I need to find the volume of the surface in the first octant, so that 0 to a. And then the second integral having the variable bounds, which is from 0 to root over a square minus x square. And coming to the third integral having the variable, other two variable bounds, which is nothing but 0 to root over a square minus x square minus y square. These are the bounds. So z bounds and the y bounds, and finally the x bounds. So the bounds should be like this in the first octant, times of dx. So clearly what we take first, so these are the bounds for z, and these are the bounds of y, and these are the bounds of x. So that first integral having the z bounds, so that we need to find integration in terms of z, and then in terms of y, after that in terms of x. Okay friends, now coming to the simplification. So v equal to 8 times of the bounds of x is ranges from 0 to a, and the bounds of y is ranges from 0 to root over a square minus x square. And we need to integrate with respect to z first. For the constant 1, what we left, it is 1. So for 1 it is z, and the bounds are from 0 to root over a square minus x square minus y square into dy into dx. Okay friends, now substitute the boundaries. So v equal to 8 times of the bounds of x is what, 0 to a, and bounds of y 0 to root over a square minus x square, it is root over a square minus x square minus y square times of dy into dx. See, now the second integral having the y bounds, so that we need to integrate with respect to y. So if we need to integrate with respect to y, treat a square minus x square as a constant. So it is a constant. So how can I write like this? It is, sorry, v equal to 8 times of x bounds are from 0 to a, and the y bounds are from 0 to root over a square minus x square. And coming to the constant bounds, so it is root over, I write constant as a square minus x square. Clearly it is the constant. Why? Because we need to integrate with respect to y. It can be written as root over a square minus x square whole square, and then minus y square, so dy into dx. So please see this constant, so please don't confuse. So it is a constant, so a square minus x square can be rewritten as root over a square minus x square whole square. So clearly this one is the constant. So we already known about root over a square minus x square dx is what? So clearly it is x by 2 root over a square minus x square plus a square by 2 sine inverse of x by a plus a c. So this is the formula for integration of root over a square minus x square. Now coming to the simplification, so clearly v equal to, so 8 times of x bounds are ranges from 0 to a, and coming to the integration of this, please see this is the constant and this one is the variable, so that y by 2 to root over a square is what, this one as a square minus x square minus x square. Here the variable x is what? Y. So that plus a square by 2. So clearly a is what here? Root over a square minus x square can be treated as a constant. So a square, which gives a square minus x square by 2. Okay students, so a root over a square minus x square can be treated as a square. So clearly we need to find a square. So a square is what? A square minus x square by 2 sine inverse of x by a. X is what here? Y by a is what? Root over a square minus x square, and the bounds are so 0 to root over a square minus x square. Now coming to the substitute, coming to the upper boundary, root over a square minus x square, we need to substitute in place of y. So if you substitute root over a square minus x square here, a square minus x square whole square, so both are same, a square minus x square and minus of a square minus x square both gets cancelled, so that which gives 0. So 0 to x bounds are from, so that it is 0 plus and a square minus x square by 2 sine inverse of root over a square minus x square by root over a square minus x square. So coming to the lower boundary, so minus of, if you substitute 0 here, 0 by anything is 0, 0 times of anything is 0, so that so it is eliminated. So that coming to the next one, a square minus x square by 2 into sine inverse of 0. Clearly sine inverse of 0 is what? 0. So a square minus x square by 2 times of 0, it is also nothing but 0. So clearly a square root over a square minus x square and root over a square minus x square gets cancelled. So v is what? 8 times of integration of 0 to a. So take 2 outside the denominator. What we have? A square minus x square times of sine inverse of 1. Clearly what is final integration in terms of dx. So sine inverse of 1 is what? Pi by 2. It's a constant, put it outside. So v equal to 2 1s are 2 4s are 4 1s are, and the constant pi by 2. So integrate root over a square minus x square. Clearly a square, for a square it is a constant a square x, minus for x square it is x cube by 3, on the bounds are from 0 to a. So now 2 1s are 2 2s gets cancelled. So 2 pi times of, now substitute the upper boundary, a square into a is what? A cube minus a cube by 3. Coming to the lower boundary 0, no need to substitute. So that 2 pi times of a cube minus a cube by 3, it is 2a cube by 3. So 2 times of 2, so 4 pi a cube by 3. So this is the final answer, is what? Volume of the sphere by using triple integral. So that, okay students, thank you.